Hey everyone, how are we doing? I was muted there. Good to see you here. Maya, Victoria. We have here William, Reagan, Tara, Evan. How's everyone doing? Epic intro as usual. Thank you very much. Let's head over to the main screen. We got the Kahoot code up and we're about ready to get started. Here we are on the main screen. Dawson, good to see you. We're going to get some good music going here. We got to get the disco music going. 2 seconds here. Disco Kahoot. There we go. Now we got the disco Kahoot. Reagan, good to see you. Jordan, good to see you. Who else we got in the chat? How much do I have to pay in bribes to win this Kahoot? I don't know. Bright knew is going to win. Mystery Dolphin. I like that right there. Bright Hawk. Kahoot music's better than all other music. I couldn't agree more. Good to see you here, Caleb. Hayden, good to see you. Allie, good to see you. Look at all those crazy like zombie and unicorn creatures. Captain Pig, but it's a unicorn. What is he rewarding for the winner? Let's go. Everyone on the winning leaderboard gets $20 Amazon or Starbucks gift card. Please email me afterwards if you won. Just email me bstevens@utkid.edu and let me know you won. People have been doing it. Someone emailed me today and said they won the other Kahoot and I sent it right away. So let me know. $20 first, $20 second, $20 third prize. Can we get, how many people do we have watching? We're going to go for about 2 more minutes getting ready here so we don't wait too long. Yo, Kelsey, good to see you here. Captain Falcon. Is there seriously Captain Falcon? Falcon Punch. Falcon Kick. Show me your moves. I'm trying to think of other things Captain Falcon says. Show me your moves. Anyone ever play F-Zero besides me? What's up, Wes? Good to see you here. Any other F-Zero fans? F-Zero on the SNES is kind of okay. F-Zero on the GameCube is insane. That I should I should get a GameCube with an HDMI out and play that on like an LED TV or an OLED. The exam starts on chapter 7, goes through decision trees, and chapter 13's. I know him from Smash. Yup. From Smash Bros. I think he's in the original Smash. Is he one of the originals? One of the original 10? I'm trying to think how many there are in the original Smash. Like, he's in Melee. It's like Pikachu, Samus, Yoshi, Jigglypuff. I'm trying to think who else is original. Like, who's original Smash? And we'll get started here in a moment. GameCube is unmatched. Yeah, GameCube was really... N64 was good, but then GameCube was next level. And then Wii was next level. And then a lot of people forget about the Wii U. Kirby, Luigi, Mario. Yeah, Jigglypuff and Kirby are like near identical. Oh, Link? Was Kid Link in the first game? Or Toon... No, Toon Link wasn't. Dr. Mario? Is Dr. Mario in the first game? I'm talking very first Smash. N64 Smash. Young Link. But is he in the first... Is he in original Smash? We're getting started in about 30... He is? I guess he is. About an hour. There is the review afterwards. Shout outs to Alyssa. Alyssa is an absolute all-star. So go check out Alyssa's review after this. We're going to get started here in 30 seconds. Toon Link main. Samus main. Samus or Pikachu. Little Pika Thunder. Or whatever that is when you just rain thunder down on them. Back kick. Or you do Samus like backwards throw. And Meta Knight. Yeah, Meta Knight's in the... That's not going to be the first one, right? Did you already get about the hoodies? We have. They've been reaching out, contacting people. Adam's been reaching out, contacting students about the winners. Thank you to everybody. I'm going to be reaching out about the student council, like the student leader council. Just, it won't be a big thing. It'll be like to bounce ideas off you and also maybe to rate the faculty on how they're doing on their online education. We want to get a lot of responses from students. I've been reading over everything, and one of the big things students have said, so we'll get started right after I say this, is a lot of students, multiple students said, I don't want faculty doing every single technology that exists. I want them like to get good at what they have and what they use. That was like, I saw a few students saying that. It's not about like changing and using the best stuff. It's about using what we have really well right now. That was a very common theme among responses. So I've been reading over, like I've read most all the responses, but yeah, I just go through and I just read, and try to put it in. Yes, not everyone is good at everything banned Panopto. Well, yeah, we're trying to, you know, so we need to focus our energy in some directions. I think that's what I'm getting from students is focus your energy. Don't have it be everything. So with that, I need some I'm ready's in the chat. I need some I'm ready. So here's the biggest thing. Today, we will be reviewing Where else can you go? If anyone asks, where can I go? Julia's ready. We got everyone ready in the chat. We got some I'm ready's. Anytime someone says, where can I go to review? Review page 2. Review 2. Dewani's ready. Nice job right there. Timothy's ready. Here we go. We're starting up in 5, 4, 3, 2, 1. Let's do this. Review 2 time. Roommates in the chat. Love it. First question is, 2 events that can be easily added together must be what? 2 events that can be easily added together must be what? For them to be easily added together. Easily. There is a way to do it if they're not this, but you have to subtract out the intersection between them. And one thing I want to point out right here, which we're going to see in just a second, is if you have questions on this, what should you be looking at during the test? The code's in the bottom right there. Good question, Tara. It's on the bottom right there, 3946216, down there at the bottom. So where can you go if you... Ooh, you see we got half and half. So where can you go? Did that not do it? In new window, here we go. Where can you go if you have questions about this? Where could you go? Where could you go if you're like, I don't know if 2 things can be easily added together? Let's go look over here and look at the formula sheet. What does the formula sheet say right here? This is the addition rule. And I just want you to see this. This is very important. Remember, about half the people got it right, but I want you to look at this. A or B. So would the question make the mutually exclusive or disjoint? They are the same thing. They're synonymous words. Good answers right there. They are synonymous words right there. So mutually exclusive and disjoint mean the same thing. When you think of what disjoint means, let me draw for you what disjoint means. No, don't worry. We're here to practice. If you get things wrong, you're in the right spot. So if you have your parents say you can get a dog or a cat. If they are mutually exclusive, what does that mean if you get a dog? Like if you get a dog, what does that mean about you getting a cat? The answer was mutually exclusive, disjoint are 2 things that can be easily added together, dog or cat. What does that mean? If you get a dog, you can't also get a cat. When things are not mutually exclusive, that means there is a time when what? So if A and B are not mutually exclusive, we'll just highlight this. So here's A over here on the left, looks like a Venn diagram, and here's B. And what does that mean? Both can occur. So things that are mutually exclusive are things like your grades in a class. Grades in a class, like getting an A, a B, a C, a D, and F in a class, are all mutually exclusive. Now, things that are not mutually exclusive would be like drinking coffee in a day and drinking Coca-Cola in a day. Maybe I'll drink a Coca-Cola later. But those are not mutually exclusive. They can happen at the same time. To test to see if something is mutually exclusive, say A happened, and if the other thing is mutually exclusive, what does that mean about B? This is the test. To test to see if things are mutually exclusive, to test this, to test if something is mutually exclusive, ask yourself, A just happened. So what would this mean? Now you'd say here, this means B can't happen. So if they are mutually exclusive, think about exclusive. They are also disjoint, which means they have no overlap. They are disjointed. So don't start blending words here, because we're going to start talking about some other words like independent, dependent. To test something mutually exclusive, you ask yourself, A just happened. And if B is mutually exclusive, B cannot happen. So a lot of times your parents are getting you an animal. They say you're getting a cat or a dog. And so if you get a cat, you're not getting a dog because it's mutually exclusive. Now, maybe you got cool parents that let you get a cat and dog, and so then it would not be mutually exclusive. If you can get both. If you can get a cat and a dog, they are not mutually excluding each other. So make sure to review those. And what is a good way to make sure, or just to look and get the answers right on the test? If you see something like this on the test, where could you go? Where could you go? Disjoint means the same thing. It's synonymous with mutually exclusive. is just a synonym. Another way to say mutually exclusive is disjoint. And look at the formula sheet. So this could say A and B are disjoint. Same just wording right there, just different way of saying it. So good answers, good job. And make sure to review. These are the same words, hence why they're both the right answers right there. Great job. Let's see who's in the lead. Remember, if you're getting questions wrong, please stay. If you're getting questions wrong, you're in the right spot. And we want to throw you some points. Let's throw everyone 5,000 points for just being here. We'll throw some crazy points at the end. But shout outs to everyone for being here. Remember, if you're getting them wrong, hang out and get more wrong to learn. The formula sheet can be found on the Review 2 page. Review 2, I'll put it in the chat right here. Review 2 is right there. Go check out the Review 2 page, and that's where you'll find the formula sheet, which you can print off or write down. Just make sure if you show it that it just has the formula sheet on it. Let's do this. Here we go with the second question. Two events that have no influence on the probability of each other are said to be what? Two events that have no influence on the probability of each other are said to be what? So this means if A happens, it tells you nothing about B. This is a test we'll do, and I'll mention this is the test for what. But you would say A just happened. So you'd be like, I know A happened. Does that tell me anything about B? I know A happened. Does that tell me anything about B? And if it tells you something, the two things are not this. If it tells you something, wow. Great work. Awesome work. So great. I think people are listening in. That's what we want to see right there. So the test for independence is, let's write down the test. You ready? Okay, so independence test. A just happened. That tells me nothing about B. If they are independent, that tells you nothing about B happening. That tells you nothing about B. So, and great work right there. So let's say the temperature outside and snow, are those independent or dependent? Take a vote now in the chat right here. The temperature outside and snow, is that independent or dependent? They changed the way the polling is working, so I have to go here. Independent. I typed independence, or people are getting it. It's very dependent. So great job. I was going to do the poll, but people are getting it very quickly. It's very dependent because snow depends on the temperature. So let's say 90 degrees and snowing. Is that disjoint or not disjoint? So is 90 degrees, I'm changing it up on you now. Is 90 degrees and snowing disjoint or not disjoint? I'm changing it up because everyone's got independence down pretty well. 90 degrees and snowing, is that disjoint or not disjoint? So remember the test for disjoint, not disjoint? And everyone's getting it. Great job right there. So the way you test this again is you say, it's 90 degrees out. Can it also be snowing? And what do you say immediately? Like so you think the event 90 degrees and the event snowing, and Ria's got it right there. Great job. Exactly. 1,000 points. Then you'd say it can't also be snowing. So those are disjoint events. The event of 90 degrees and the event of snow can't happen at the same time. I just don't think it's possible. So those would be disjoint events right there. The disjoint definitely is the easiest one. It is. And then just remember, disjoint means no overlap. Like think of two circles that have a joint. That's the way I keep it straight in my head. They have a joint right there. And disjoint means there's no overlap between it. So that's a good way to help remember it. Also, it means mutually exclusive. Like if one happens, the other is excluding it. So good stuff right there and good practice. Next question, we're going to try to end by 8. So if you want to run down to Alyssa's review, check it out. And huge shouts to Alyssa. Can we get some shouts to Alyssa in the chat? Get ready because we're going to start the next question. But check out her review at 8 p.m. tonight. So we're going to try to make it and go a little bit quickly, but keep asking those questions and keep answering. Stay focused. Let's do this. Next question. To multiply the probability of event A and event B, the events must be what of each other? Now, if you don't know the answer to this, look at your formula sheet. Quickly go to the Review 2 page and look at the formula sheet because the formula sheet has the what we need, and there is the addition rule and the multiplication rule. So a lot of these things are very similar, like independent and dependent are the opposite of each other. Mutually exclusive and disjoint are synonymous. They mean the same thing. If you go to the formula sheet, Blake right there, great job. If you go to the formula sheet, you will see the multiplication rule has with it the independence condition. And take a look, we only had 37 people. Oh no. Oh no. So go check out the formula sheet. You ready? Right here on the formula sheet, here is the multiplication rule. So to multiply two events, I picked, no worries. Disjoint is, and don't worry, Kahoot's a little bit different. On the exam, what are you going to do? Are you going to go as quick as possible? Or are you going to go look at the formula sheet? This is one of the things I'm trying to point out right here. Don't worry, Caleb, you're doing great. What are you going to do? You're going to go to the formula sheet, right? So what does the formula sheet say right here? If you are multiplying two events, they need to be what? If you're multiplying two events, they need to be what? If you're multiplying two events, they need to be what? Take a look at the formula sheet right there. Probability of A and B occurring is the probability of B, A times B. Can we use the formula? You can't use notes, but you can use the formula sheet. And if you don't have a printer, you can write down the formula sheet. Just make sure to show it, and you can't bring additional notes to the exam. But here's the thing. Grab a calculator if you don't have it. We're just going to take 30 seconds right here, or have your phone ready with a calculator. Probably grab a calculator like you probably use for exam, because I'm going to have some tricky questions coming up here in a second, like some at least one questions. So just giving you a little warning on that. You can get ready here. We got 15 seconds till the next question is about to start up. So another thing we're going to be doing way later is we're going to be practicing our written interpretations. So get ready for those coming up near the end. Written interpretations with regression is going to be very important. 12 points of the test. I'm going to give you lots of tips for those, and we're going to make sure we get them down. It is time for the leaderboard. Knowing Kitten. Oh, that's cute right there. Where's Captain Falcon? You got to come on, Captain Falcon. You got this. Falcon, win. Let's do this. Next question. A probability of a gross jelly bean is 0.25. If you eat 3 jelly beans in a row, what's the probability that they're all good? So first you have to figure out the probability of a good jelly bean. So let's slow it down. Probability of a gross jelly bean, when you eat those, like those, you get those, like, what are they called? Like the Harry Potter jelly beans. And you're like, I don't know, one of these is going to be like, what is it? Like fish, like rotten fish. And you're like, or it's going to be like cranberry. And you're like, oh yeah, it's cranberry. Okay, we're good. You know what's the one I really don't mind? Toothpaste. Like I use toothpaste every day. So why would I care if I eat a toothpaste jelly bean? It's not my favorite, but I mean, come on, that's not gross. So what's the probability of a good jelly bean? 0.75. What is the probability, and regardy? Think about this. The first jelly bean you eat is good. And, yeah, the barf one's gross. Bean Boozled, yeah. The second one you eat is gross. I mean, good. And the third one you eat is good. So think about this. Oh, no, Rhea. Can anyone explain to me what Brian's saying? I'm literally telling you the math. The first one you eat is good, and the second one you eat is good, and the third one you eat is good. Do you think each jelly bean cares about the previous jelly bean? What am I telling you by saying each jelly bean would not care about the previous jelly bean? Mariah, great work right there. Yes, Mariah sees it. Each jelly bean does not care about the previous jelly bean. So the mathematics is going to be 0.75 for the first jelly bean being good. Great job, Julia. And then 0.75 for the second jelly bean being good. And then 0.75 for the third jelly bean being good, which is going to be one of those two on the left. It is that yellow one down there. Good work. Don't worry if you got it wrong. The other probability would be what? So, I mean, maybe that's one of the ones I wrote next. But if you take 1 minus that, either all the jelly beans are good or what? Because this is the probability that every jelly bean is good, or what? How would this probability be described, which is 1 minus? So this is the probability every jelly bean is good, or at least one of them is not good. So either it is the case that all 3 jelly beans you get are good, or, oh, right down there at the bottom right there, at least one of them is bad. Great job, George, right there. So either every jelly bean is good, and that's the probability in yellow, or at least one is a bad jelly bean. Because they could all be bad, all 3 or 2 or 1. Does that make sense? Gross. So great work right there, and practice along. This is the multiplication rule right here, because you have the first you eat, and then the second you eat, and the third you eat. And say it with me again. Each jelly bean's probability of being good is what of the last jelly bean. Hence why we can multiply them. Each jelly bean's probability of being good is what? Because the last jelly bean doesn't matter. They are independent. That's what it means to be independent. Like this jelly bean here and this jelly bean here. If this one's gross, it's not going to change the probability of this one being gross. That's what independent means. Great job, Dalton, Tara, and Kelsey, and Mariah. Let's check out that leaderboard, see who's winning right here. Knowing Kitten knows all, but Swift Swan swiftly jumping to the lead right there. Look at the alliteration on all this. You have to have alliteration to win these days. Here we go. This one, it was the multiplication rule. 0.75 times 0.75 times 0.75, because each jelly bean's probability of being good is independent of the previous one. Here comes another question. Let's do it. So now the probability of getting a multiple choice question right is 0.8. With 5 questions, what's the probability you get at least one wrong? So here's one of those, at least one question. So you've studied up for the test, and you have an 80% probability of getting it right. So I'd write down first, 80% probability right. So what's the probability you get a question wrong? We won't actually use it, but if there's 80% probability you get a question right, what's the probability you get a question wrong? Just a singular question. What's probably you get a question wrong? People are like solving it right now. So if you have an 80% probability of getting it right, 0.2 to get it wrong, right? What would you like on this? What would you like to occur? What would be your dream scenario with 5 multiple choice questions? What's your dream scenario? You've got 5 multiple choice questions you have to answer, and you have an 80% probability of getting the first and the second and the third and the fourth and the 5th right. You'd love to get all 5 right. Either you will get all 5 right or what? Either it is the case that you will get all 5 right or what? This is what we have to do, and I'll show how to write this down in a moment. Or you will miss one. And that one of those two things must occur. So let's figure out the probability of all 5 right, which is 0.8 times 0.8 times 0.8 times 0.8, 0.8 to the 5th power, and then subtract that from 1. We're going to take a look at this in a second right here. I am worried. I think it's the yellow. I think it is. I'm just doing it from like the way it looks. No, it's blue. Wow. Oh, I should have. Oh, that's the probability you get them all right down there. So, and great job, Daniel, right there. Daniel, we got to throw you 1,000 points. Daniel got it right. That is the mathematics for it. Let's go show this right here. Well, never mind. Moira got it right. I think so. Daniel, great job right there. Awesome work. Let's show the mathematics behind this. Oh my gosh, look at all the colors and everything. That was the M&Ms. Okay, so the probability of getting a question right is 80%, 0.8. I thought I understood. No, this is just practice. This is the at least ones. I put some of the toughest stuff on here to do. So you got this, Shelby. This is the practice. These are the toughest questions. So think about this. Probability get all 5 right. This means the first question you have to get right, and the second question you have to get right, and the third, and the fourth, and the 5th. What is that if you want to write it out? But what's the probability you get the first right, and the second right, and the third right, and the 4th right, and the 5th right? If you hear my words right there, very precise on first, and second, and third, and 4th, and 5th right. So get it wrong here, get it right on the test. Blake, great job right there. And so people are great job, Shelby, right there. There it is right there, Shelby, 1,000 points. Keep it up. And Blake, great job. 0.8 to the 5th power is probability you get them all right. Do you agree that it is the case that you will get all 5 right or at least one wrong? And you'll spell at least wrong. Do you agree that it is the case that either you will get all 5 questions right on the test or you will get at least one wrong? Does that make sense? Hopefully people are learning how to solve these questions with. That makes sense, right? So what is the probability of those added up? If it is the case that either this will happen or this will happen, then what would that be? That would be one wrong, Rhea. Good answer right there. The probability right there would be this right here. Does that make sense? So think about this. If we know the probability of this, we could solve for the other one by doing a little algebra. And it might help people to see it this way. You could just call this y, or actually we want to call it x because we're going to solve for this one, y, and then the or means addition. Does that make, I hope that makes a little more sense maybe to see it that way. And you're like, oh wait, it's just, this is a probability plus this probability equals 1. So then when we take this, we're just going to take this one over here and subtract it from the other side. Does that make sense? Good job. Yeah, sometimes you see it and you're like, oh, okay, I see it right there. So all we're doing is just algebraing it over to the other side, and then we just have to know the probability of getting all 5 correct, which the probability of getting all 5 correct is the probability you get the first right and the second right, and I'll disappear here, and the third right. You can write this out as 0.8 to the 5th power. So that is the probability of getting all right. And this is everything but getting all right. Thank you, Blake. I appreciate that. And so this is the answer right here mathematically, Samantha. And here I'll show it also by solving it. 0.8 times 2, 3, 4, 5. That's pointed to the power. That's the probability of getting all things right. That's the math right there. And then 1 minus that is going to be the probability of at least one wrong. During lecture tomorrow, are we going to be doing even more in class review? We'll be doing review on Wednesday. Tomorrow we are finishing up the chapter 13/mean. Here we go, on to the next question. Let's do it. Here's the leaderboard right here with Knowing Kitten and Swift Swan. You're welcome. Here we go. Next question. What is the which of the following is a rule of probability? Which of the following is a rule of probability? I think you should get this pretty easily, but it's a great chance to review Chapter 7, which we have a little bit of Chapter 7 throughout here. Those other things are conditions or rules for what? Those other things right there, and there's a fourth one, but it's not on the screen. What are those other things for? Correlation. Great job, Shelby, right there. Those are the correlation conditions. QQ, straight enough, no outliers. And then the fourth one for regression also. So they are correlation and regression. The fourth one is going to be plot doesn't thicken, which looks at the residual plot. I'd take a note on that. Plot doesn't thicken is the regression condition that states the plot should not get any thicker on the residual plot or just on the plot in general. So the condition or the rule for probability is all probabilities are contained within 0 to 1. They could go as low as 0 or as high as 1, but probabilities cannot be outside of that. QQ means two quantitative variables. That means on regression, both variables are quantitative. Straight enough means the line goes straight through the data. No outliers means there's no outliers. This might be a dumb question, but where does the one come from? Is it because something must be... good question, Sydney. Let's rate 1,000 points. Thank you, Sydney, for the question. Where does the one come from? I'm going to throw another 1,000 points if anyone can tell me why we know that it's 1. That's such a good question right there. Let's throw 2,000 points to start. Why did we know in that previous example that when we take the two things right here, so we have right here two things, and why would we know that their probabilities add up to 1? So we have here all 5 right, and then there was or at least 1 wrong. And so why do these two things add up to 1? Why do they add up? And this is another rule of probability, the third rule of probability. The third rule of probability, and Ali, amazing work right there, is describing the complement. Thank you, Dana, right there. Ali's describing the complement. The complement is either A or not A. So either it is the case that you will get all 5 right, or you will get at least 1 wrong. What is the probability of this? Tomorrow, you will either get a dog or not get a dog. What is the probability, if we were to say, looking at this right here, the probability you get a dog or not get a dog tomorrow would add up to what? It add up to 1. And you might say the other one doesn't look like that because you say at least 1 wrong. So why don't we describe this as all 5 right or not all 5 right? So if you don't get all 5 right, then you've done 1, because either you're going to get all 5 questions right or you're not going to get all 5 of them right. Be careful, it's not getting them all wrong. So what does it mean to say you didn't get all 5 right? That means what? Like if you say, I didn't get all 5 right, that means what? Which you can write the complement that way. What does that mean right there? Because now it looks more like a compliment to say it that way, but it's a little hard to understand. So either you get all 5 right, or not all 5 right means what? I didn't get all 5 right. So I didn't get all 5 right means I got at least 1 wrong. Does that make sense? Rio, great job right there. So that's why you might have gotten 4 right, you might have gotten 3, you might have gotten 2, you might have gotten 1, you might have missed them all. You didn't get all 5 right. So that's why it is the same thing to say not all 5 are correct. So then we just might say at least 1 was wrong, which is the same thing. Now it's more looking like the complement, though, to say all 5 right, not all 5 right. And so the complement plus the other event add up to 1. Good review right there and good questions. Please ask every question. We're here to answer them. We're here to practice. Leaderboard, Knowing Kitten, Swift Swan, and Witty Unicorn. You look like a monkey. You look like a ghost. Next question. A researcher selects the first 20 roads near their house. What kind of sampling did they do? Now, this is all about the note cards. Have your note cards out. Make sure, and you're welcome, Sydney. Have your note cards out and make sure to be reviewing these definitions. You want to have a definition for each one of these and be able to do examples. Like if I said, what is a cluster sample? You'd be like, maybe they take 5-mile segments of road. What is stratified? Maybe they take city road versus country road. What is systematic? Maybe they take every 5th mile on a stretch of road. They go down a road and take every 5th mile and survey that for potholes. What they're doing right here is a convenience sample, and you definitely heard some hints if you're listening carefully for future questions. Convenience sample is when you get the things closest and nearest to you to collect on. This chapter right here on sample surveys is 100% definitions. And if you thought that my Pearson quiz was hard, I've got great news for you. The test is way easier. We don't want any confusing, crazy questions on it. So we are very much by the definitions. You're going to be hearing them tonight. So make sure to write down the definitions. So let's practice. What is a convenience sample? I want you writing it in the chat. It's one thing to see me write these down, but I want you to write down a definition of convenience sample. I want you to think of an example of it, and you gotta be like, convenience. That's when someone does things easily and it's biased. So convenience sample is not a random sample. They pick something, maybe they just reach out to their friends. The closest and easiest thing is to get to, and it's not a random sample method. So it's convenient for someone to get something near them. Exactly. So that's what convenience sampling is. Convenience sampling is when you get the closest and easiest things to get. It's biased. There we go. Selects the first 20 roads near their house. They say, I need to go look at roads. Let me just drive down the street and see what I see. That's not a good way to do it. Asking questions to the first 15 people to walk in the building. Exactly. Great work right there. Catherine and Kayla and Mariah. Good examples. Remember the examples and remember how to define it as we do more of the sampling chapter. Here we go. Knowing kittens still in the lead with Swift Swan swiftly on their tail. Next question. A researcher selects every 5th road on a list of roads. Now, actually, the first thing you do when you do this sampling method is to randomize the whole list and probably pick a random starting point. But the big part of this sampling method is the t. I don't want to exit out. I want the t. Every time you see t, you should think what, like the 10th, the 20th, the 15th, the 30th. It's a giveaway on the question. So might as well be free points if you see t, systematic right there. Great job, Maura. You got it. When you see that t, then you know it. So I do want to reiterate again, they actually pick a random starting point. So if a question says like pick a random starting point, and I wouldn't like it if it's a multi-stage, but you don't want to just start from the beginning. No worries, Ria. It is systematic. Remember, we're here to practice, so keep answering questions. Systematic is when you pick a random starting point and then, thank you so much, Lauren, right there. Systematic, pick a random starting point and then select every kth observation. Write that down. I'm going to repeat it 2 more times. Systematic is when you pick a random starting point, you just have to start at a random spot, and then you take every kth observation. Kth is just a placeholder for standing outside the library and talking to, we'll be doing that here soon. Kayla, good question. So it's just a placeholder. The kth is just a placeholder for every 20th person, every 50th person. Think about this. Do you think a car company would crash test every 4th car or every 100th car? What do you think they would do? 4th car or 100th car? If you're running Nissan, you say we need to do a crash test on, I'd probably do every 100th. Probably, I mean, maybe they do every 4th car. They want to make sure it's new in spec, make sure it's doing a good job. They could, but you're going to probably destroy your product. So that's why you might say every 100th car is crash tested to look for safety. Do a...
Wow.
Oh, Logan, you kill him. Oh, Caleb. Wait, who's that? Logan said it. Yeah, Caleb also. I like that stat to one humor. Do a census. Yeah, you got to know what a census is. So what did Logan suggest right there on the cars? You gotta know what a census is to understand the joke there. He's suggesting what? This is a good review of a census. We gotta throw you 5,000 points for that. That's perfect joke to review humor. If you can make a joke like that, you understand the term and you understand, yeah, let's not do a census on our cars to crash test them. Let's not get data on all the cars. We're going to take a sample to understand the population of cars. I don't see why we would. Well, so if you do a crash test, you're probably going to destroy the car. Does that make sense? You're probably going to destroy the car. I'm assuming that's what a crash test would. I'm not saying stress test to make sure you make sure things don't break at a certain stress level to put it out to, be sold. But Oh no, don't do that. So we're all having fun here, all having a good time. And on we go. Let's go to the next question. Here we go. Here we go. Let's check it out. A researcher lists all the roads and randomizes them and then selects the first 50 cars. Yeah, thank you so much for being a good sport. They're all having some fun. I appreciate it. As long as everyone's being positive and we're having a great time. A researcher lists all the roads, randomizes them, and then selects the first 50 roads. This is a rather interesting question that has history to it because we said something like the registrar has a list of UT students, randomizes them, and then selects the first 50. Now, here's the thing. The roads have all been what already? Ooh, I tricked people. The roads have all been what? The roads have all been whatted now. Well, no one selected it. They've all been randomized. This is just a simple random sample. A simple random sample is, so write this down. You ready? Or have your note cards out. Nice job, Victoria. So a simple random sample is everything gets a number, and then you randomly select the numbers. If you randomize the order and then you select the first 50, they've been randomized. So all you do is everything gets a number, and then you randomly select the numbers. What are the steps for a simple random sample? The steps for a simple random sample are everything gets a number, and then you what? What's the rock? It matters! It matters from the rock right here. Random sampling matters. So you randomly select the numbers. Great job right there. We're all practicing right here. So remember, the order of simple random sample is everything gets... So you ever see those like the 1.9 billion lottery tickets are... Brian's not pro lottery. I mean, I'm pro having lotteries, but I'm not pro buying lottery tickets. I mean, if you get a little bit of enjoyment, just remember, any money you spend on lottery, be willing to lose it. Just life advice with Brian. So yep. And so those balls inside the lottery machine right there, that is going to be a simple random sample. Because everything, and here's a good thing to remember too, in a simple random sample, every one of those balls should have a what probability of being selected. Every one of those balls, this is a good review also, in a simple random sample, every one of them has a what probability? You wouldn't start at the beginning. You would just randomize everything and then select randomly. Or like, since it says select the first 50, it's already been randomized though, and everything has an equal. So since they've been randomized, the first 50 roads are just 50 random roads. That's the tricky part of this question where we tricked a lot of people, but it's the first 50. It's convenience. A lot of people said stratified and people said cluster. More on those in a second. So get ready here. Let's go check out the leaderboard and review some terminology. Oh, leaderboard shakeup with Witty Unicorn, the Professor Monkey in the lead right there. But no one kidding. Let's keep going. And remember, we're here to practice. Write down the terms as we do this. Let's check it out. Number one, baby. A researcher selects their sample based on the percent of highway roads, country roads, and city roads. They are acknowledging a difference right here. They're acknowledging a difference. That is the key thing about this sampling method. In this sampling method, you're guarding against under coverage, which is when you do not have enough of one group. So you're ensuring you get enough of that group in there. So this one right here, I think it's one of the key examples. You're acknowledging a difference, and then you're not taking all of that group. This is not the answer. You're not taking all of that group, or if you got it wrong. So you see it's 50-50 between cluster and stratified. How do you know this is stratified? In stratified, what will you always do with the groups? What are you going to do with the groups? If you are stratifying, you must do what with the groups? Like the reason you stratify is because of this. Like I've got it up there. You're going to acknowledge a difference and then sample accordingly. In cluster sampling, you take all of one group. Does that make sense? So if highway, country, and city roads were clusters, what would they be doing with those clusters? They would take what of a cluster or multiple clusters? If you are cluster sampling, clustering, you would do what? Think about buying a box of donuts. You do a census. Logan, you got some awesome answers tonight. Logan, I don't know why you're not a mod. Logan, everyone give shouts to Logan, our new mod with 1,000 points right there. Thank you, Logan. Amazing answers, amazing jokes, great answers, and good stuff right there. In cluster sampling, You randomly select your clusters, which have been randomly put together. It's like you walk into Dunkin' Donuts and they got a bunch of 12, like a bunch of dozen donuts, and you're like, give me 3 clusters of donuts. And then you're like, what do you mean a cluster? You say boxes. Each box of donuts, if you're doing clustering, is basically what of the other boxes of donuts. Each box of donuts is basically what of the other boxes of donuts. It's just a box of donuts. We're talking about clustering here for a second. Clustering, each box of donuts is basically what? Like there's a box, there's a box, there's a box. You walk into Krispy Kreme, there's a box, 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 there's a box. It's probably about the same, right?
It doesn't matter.
Rock knows all the answers. It's basically just a box of donuts. Why do you do cluster sampling? Why do people cluster sample? To what the process of sampling? Like instead of just taking a donut, you could take a box. So the box of donuts is going to be what? It's going to speed up the process. So cluster sampling is taking a whole bunch at once when the whole bunch you're taking is basically just a group that has been randomly put together, and then we're taking it a lot quicker. So clusters, we'll talk more about that in a second, are randomly put together groups, and you randomly select the group. So you do use simple random sample, but it's not a multi-stage. It's just where you use simple random sample to randomly take boxes, donuts, or clusters. But when you stratify, to bring it back right here, you must do what with your groups? When you stratify, you must do what with your groups? You must do what? Have this written down. When I stratify, I must do this. I must make sure in the question I am doing this. Acknowledge a difference. So if you're going to acknowledge a difference, like, be careful. If somebody were to say, like, we are going to go collect blood and see if there's like some sort of pathogen in people with A, B, C. There's no C. A, B, A, B, O. I don't know blood types. It's not what I do. So if we were to take within each group, then that would be stratified. But if we were to take all of the people with A blood, that would be what? Like if we said, let's just take everyone with A blood and just go reach out to them. Just call everyone on the list who has A blood. Call everyone on the list. That would be a what sampling method? Call everyone on the list with A blood. That is a cluster. So sometimes we'll do things like that. So when you do clusters, you always do a what. And Logan, shout out to Logan right there, knows you must do a what on your clusters. If there's a cluster, you're doing a what on it. Anyone else have an idea? Is that universal denominator receiver? One of those two. You do a census. I'll ask you 2 more questions. How would you stratify donuts? How would you stratify donuts? So you want to go check out Krispy Kreme to see if they're meeting their standards. If they have good donuts, you're going to do some ratings. So you could do flavors. You could do glazed versus filled. Does that make sense right there? Like, okay, we're going to try some glazed. We're going to try some filled. Now, if glazed and filled were clusters, what would that mean about selecting glazed donuts at Krispy Kreme? If glazed was the cluster and not a strata, what would that mean you'd be walking into Krispy Kreme and doing to get your data on glazed donuts? What would that mean if it was a cluster, not a strata as it should be, I think? What would it mean? Great job, Kenneth, right there. If glazed was a cluster, well, we would probably want to get boxes. But if all of glazed is a cluster, that means you have to try all the glazed donuts. You have to do a census on glazed donuts. Does that make sense, the difference right here? Good bit of review. I might do a few more practice near the end, but a lot of people, cluster and stratified is the big confusing one because they're basically both groups. Stratified acknowledges differences and samples within the strata. Cluster is going to take a whole bunch at once and assume everything is basically the same. What's the plural of census? Sensei? Sensei? Like karate? Oh, there we go. Witty unicorn. Great job right there. It's census, I think. It might be. It probably is. It's probably one of those weird words where the plural is the same word. Next question. Let's do this. A researcher decides to take 5-mile segments of roads and sample each 1-mile segment within. So they're going to each 5-mile segment and then doing a census on it. Oh my gosh, it's like we got a review of terms right here. So in this sampling method, you are going to pick randomly the groups and then do a census on each one of the groups. Now it's not multi-stage because you just have to find the groups some way. You could do it as a multi-stage, be like systematic, but it's not. But you are going to take random groups and then do censuses. Maybe we just talked about this. Good review and good practice. That's why try to keep, people practicing and hearing it and remembering it. So when you do a cluster, What is one of the key things you'll see on the test? If there's a test question dealing with clusters, weirdly worded, all my questions are. One of the things you will see, or conceptually, is that you will see a what? There will be a census. Yeah, it's pretty weirdly worded. You will see a census, and it might not say census, but it would say that they're taking all of them. Does that make sense? What a census is? You're taking all of that group, and the group is supposedly a random group, but that's ideal. But still, once again, if it's a cluster sample, there is a census done on the cluster. Go to review. Let's continue on. Here we go. Leaderboard is all crazy, but remember, if you're here practicing, that's what matters. Next question. The researcher takes too many city roads in their sample. Too many city roads. What kind of bias is this? We'll have 4 different types of bias on the screen. Convenience bias is with convenience sampling. When we get the easiest things that we can get, that is convenience bias. When we have non-response bias, that's when something doesn't respond. It's like someone calls you on the phone and you don't pick up and you don't talk to the person, and those people's views differ than the people who answer. Response bias is going to be when the habits or the behavior of the researcher influences the individual or the way the question is worded. So there's bias in the response. But this one is under coverage bias. Now, so they got too many, right? So if they get too many of one group, what does that mean for the other groups? If there's too many of one group, and I'll repeat the definitions of these again. If there's too many of one group, what does that mean for the other group? But if they get too many of something, then they get too few of the others. Does that make sense right there? So tricky question. So if they get too many of one, they get too few of another. How did we know there were multiple groups? Good question right there, Moira. There is a character limit to what I can do with Kahoots. There's I think a 70 character limit. It's not that much, so it's really hard to write big questions on here. So do expect the test questions to be more exact, and you can always question your grade, and you can always question things on the test. Who's gotten points back from me? And I want all the other people who I work with to also talk about grades, talk about what you have, and let us know. So if you think something's weirdly worded, if you're like, hey, I didn't think this was really what it meant, let us know. We're always open to critique. An over coverage is under coverage. So over coverage is under coverage. Ban the chapter. So over coverage is under coverage. What is response bias? Probably one of the best response bias questions are, is it fair that you can get married at 20 but you can't drink a beer? Is that fair? So do you think we should move the legal age of drinking back to like 18 like it was when my parents were kids? What do you think? That's a total response bias question. Like, you shouldn't be asking people, do you think it's fair that this and this? That's bias. We don't want bias when we do surveys. We ask people, what should the legal drinking age be? That's what we should ask people. You shouldn't preface it with like, back when Brian's parents were kids, the legal drinking age was 18 and everything was fine with the world. Do you think we should move it back to that? It's I don't know. It's so interesting. It's so, my parents, especially when I was in New York, everyone would just go to Canada. Oh, Canada. Any questions on any other of these? What non-response bias is? That's when somebody who doesn't answer your survey differs in the opinions than those who do answer. So a good example of non-response bias is if you see something controversial and you choose not to engage with it, then you're probably eliciting non-response bias. It's kind of similar to voluntary bias, where voluntary bias speaks more about the people who are kind of answering the survey, which is a voluntary survey. Hey, thank you so much, Jordan, right there. Thank you so much. We're going to throw you 1,000 points right there. We appreciate that. Always the positivity. Brian Suss, the great land of maple syrup. I love some maple syrup. I'm actually half Canadian. There you go. Probably my love of maple syrup. I like who's with me? Let's take a quick poll of the audience right here for the next question. Real or cheap maple syrup? Who's with me on this? Cheap or real maple syrup? Maple syrup. Cheap or real? Let's see what people say. Here we go. Make sure you're ready because we're doing another Kahoot question right here. Let's do this. Here we go. Let's see what the research says. The researcher collects roads around their house. The researcher collects roads around their house. Brian's falling asleep right here. He's going to wake up. The researcher collects roads around their house. roads around their house. They're there. They're there, Brian. It's all right. Everyone makes mistakes. They're there. They're there. At least it's the right there. At least it's the right. We had 3 different theirs. We got one. Yep, convenience bias. We don't need to review that one much more. We'll just pretend that we didn't make that grammatical error. We'll just pretend no one saw that right there. Just nothing going on right here to see. Just had some real maple syrup on pancakes. That's awesome. Only a third of the class is with me. I don't know why, but I like that cheap fake maple syrup. Give me cheap fake full of sugar, high fructose corn syrup. I don't know. I don't know what it is. I don't know why I don't like real maple syrup. I don't know. I'm sorry. Maybe I have some really good maple syrup. Or you go to Pancake Factory. Shout out to Pancake Factory. Is that the place in Nashville? Man, they got like on the table like all those crazy maple syrups or all the crazy. Man, go to Pancake Factory. Shout outs to them. Really great place to go. Here we go with the next question. The list of roads that the researcher has access. Pancake Pantry. That's it right there. List of roads the researcher has access to sample. What'd your Canadian parents say? He puts ketchup on eggs. He has no room to talk. The list of roads the researcher has access to sample, and I'm kind of blocking the right answer a little bit. Now I'm blocking it. The roads you have access to sample. The roads you have access to sample. Yeah, the line's pretty tough. Worth it though. Get there early. Okay, so this is a big one. I want to point out some key differences right here. You ready? What is the biggest group that can exist? Like, of all the things you're interested in, the biggest groups that exist is the what? Of all the things you're interested in, the biggest group is the what? The population. And that's why it's sometimes called population of interest, because you're interested in it. But that's the same thing. Population of interest, same thing.
It doesn't matter.
Does that make sense? So the population of interest is everything you want to understand. The sample frame would be the things you have what? Like, let's say we're going to go to Pancake Pantry. We want to understand their menu. We want to understand how things taste. Or let's say we're moist critical and we're going to Burger King. We're going to go order from their menu. The sample frame would be everything what? Everything you have access to sample. I heard McRib's on its last tour. If you want to sample the McRib, you might want to do it now. I'm not suggesting you do. But if you don't have access to it, it's not in your sample frame. Are there menu items on McDonald's menus in other countries that we don't have access to? Like someone's like, oh my gosh, you have to have a McPizza. I think that was a thing. So if you do not have access to try the McPizza, it is where? The McPizza is where? The lamb, the McDonald's lamb is where? I'll never forget. The McPizza would be where? If you can't get a McPizza, it's not in your sample frame. Does that make sense? If you can't get it, it's outside your sample frame. That is something that exists that McDonald's has made and maybe is currently making. Probably in Italy, who knows? So with this, and they might not allow it in Italy. It might be illegal in Italy. So right here, the sample would be the things on the menu you what? The sample would be the things on the menu you what? So the population would be the menu items at the restaurant you want to try. The sample frame would be the ones you can possibly order. And then the sample would be the what? Well, the sample will be the what here, William? So using this example of going to a restaurant, the sample will be the what? The sample will be the ones you try. The population is everything the restaurant kind of has made or could make. And then the sample frame would be the ones you have access to. Like if they will not make you the item. I used to work at Cheddar's and we had a dessert called the Millionaire. Oh, it was so good. It had brownies with ice cream with fudge and nuts. So good. Cookie Monster's great too. But they took it off the menu, so it's off the sample frame. So you don't get to find out how good it is. Only I know. Or maybe someone else knows. Yeah, it was really good. And yeah, oh, thank you there, Ali. Yep, worked there for quite a bit. And so making garlic eggs, oh, that's some good stuff, Evan, right there. So the sample is what you try. But if you are rating, if you're going to rate the things, your ratings you give is to try to understand the what. The ratings you give is to try to understand what. The ratings you give, look down there. The ratings you give is to try to understand what. The ratings you give is to try to understand what? There's still the answer on the screen. Well, the sample is what we learn from. The population is what we want to understand. The rating you want to know for everything would be called the what. Like the thing you want to know about the population, the what you're interested in understanding about it, like the true rating, like how really good is the food at the restaurant, that would be known as the what, the parameter of interest. And your rating, when you give the restaurant food an 8 out of 10, you're giving it a what? You don't know the truth. You're just taking an educated guess from your sample. Your sample gives you a what? Your sample, and these are keywords, the sample leads to a what? Your ratings on the sample, like your average rating from the sample would be known as a what? Your average rating on the sample would be a statistic. And the statistic is an estimate of the truth. The truth being the parameter of interest of the population. Let's say you want to understand, so let's do another example. You ready? One more example, and then we'll do more questions. You want to understand how many hours students study for finals. So on the last day of finals, you go to the library and you ask students how many hours did they study. First off, what's your population? You go to the library and you talk to students. What's your population? What's a good way probably to describe your population? The population would be what? All students. So remember, we want to understand students. So we're not limiting it yet. We just want to understand students. Now, what's your sample frame? What's your sample frame? So what's your sample frame? What students do you have access to now? So your sample frame would be those who are at school on the last day in the library. Can you think of any way that that's biased? So you want to understand how long students study for finals. So you go on the last day of finals to talk to students in the library. That might be a little bit biased because you're probably undercovering, great job, Ali, right there, students who went and left and went home or something, right? You're talking to students who are still around and studying for finals on the last day. So you might not be covering all students properly. The sample would be the students who speak to you. And then the parameter of interest was what? What was the parameter of interest I said again? The parameter of interest is the thing you want to understand about them. So the parameter of interest that I kept saying right there was what? I'll say it again here in a moment, but does anyone remember I said what the parameter of interest was, what we wanted to learn about them? How many hours they study, like on average, like what is the average amount of hours studied? And it would give you an estimate of the truth for all students. Now, it might be biased. We have to watch out for that. So good work right there. Good practice. Population, all things we are interested in understanding. Sample frame, all things we have access to. Sample, the things we collect data on. Statistic, the understanding we get from a sample. Parameter of interest, the truth we want to understand that our statistic is an estimate of. So good stuff. Any questions on this? Julia, does that help right there? Definition of a sample is the individuals or items we collect data on. It's the ones we actually get data on, like you get data on it. Good job right there. Okay, next question. Really good review. Know those terms. Witty unicorn. Great job. Next question. I want to try to finish before 8 for Alyssa. The roads that the researcher samples. I think you got this right now. The ones that they sample. The actual roads that they sample. The ones. I promise it's not a trick question. I promise I'm not trying to trick you. We got these. The roads that the researcher samples. The end of this will be some notation review. I know. It's the ones they actually sample. This is not a trick question. Not a trick question. I should have put like 20 seconds. That is the sample. That is the sample. That is the sample. Get ready for the next question in 5, 4, 3, 2, 1. Great job, Groovy Panda. The roads that the researcher wants to understand. So this is the roads that they want to understand. The roads that they want to understand would be called what? Is there a concern? The roads that they want to understand. Be careful. Not what about the roads, but the roads they want to understand. No worries. You might have got it right. The roads they want to understand. It was a 50-50 split. How would you describe the parameter of interest? The parameter of interest is what? So this is where people usually get confused. Populations have parameters. The roads they want to understand is the population. The thing they want to know. Great job. Yes, exactly. Wow, Allie, we're throwing you 5,000 points. Allie said it's, or Shelby, sorry. I saw Allie and Shelby back to back. Shelby said it so perfectly right there. Shelby said the thing they want to know about the roads, that's the parameter of interest. Does that make sense? The thing they want to understand is the parameter. It's just some quality. Think of parameter as quality. Like, I want to understand this. This is the parameter I want to understand. The population is the group you want to understand about. So you do want to understand populations, but the thing you want to understand about the population is the parameter. So really good practice. Try putting in your own words. Like, a lot of times people put some really greats, like a pothole. You bet, maybe so a pothole. You never know. Potholes, like how many potholes there are, that could be a parameter of interest about roads. It very well could be. Let's see here with a few more questions. Next question coming right up. Groovy Panda, great job. Ooh, close game. Here we go with the next question. Pothole. The researcher wants to understand the average amount of potholes per mile in all the roads in Knoxville. So they want to understand this sort of quality of the roads. So this is a quality. It's a thing we want to understand. What would be their best guess of this? They would have to go out and collect data, and they would gather a what? Like, unless they could do a census. Their best guess at this would be a what? What would be their best guess at this? Like, what they would make inferences from? Their best guess at this would probably be, and that's the answer's not on there for this, a statistic. But the answer for this is the parameter. You get another 1,000 points right there. Great job. And I think Shelby, that was you right here reviewing this, helping people get it down. We got really good answers on that. Great job, everyone, right there. Some W's in the chat. So good work, good practice. The thing they want to understand about the population is the parameter of interest. Parameter, what is the only word that matters in population parameter of interest? In population parameter of interest, the only word that matters is what? The only word that matters in population parameter of interest is what? The parameter. It's the population parameter. It's the parameter of interest. But the only thing that matters right there is parameter, the parameter, the thing we want to understand. So that is important right there because the population of interest, the parameter of interest, the population parameter of interest. If someone says population by itself, they're talking about everything we want to get data on. If they say parameter, they're talking about the thing we want to understand about the population. Sometimes people get complex and say population parameter of interest. That's the parameter for the population that we want to understand. So it'd be parameter. Good review, good stuff. Keep practicing. Write it down. So it's the thing we want to understand. Correct. The parameter is the thing we want to understand. Good job, Evan. Thank you for being here. Next question. Here we go. Probability of making a shot is 30%. What's its complement? Nice and easy, quick question right here. How do we find the complement? And this is very important for P and Q, which is coming up here in a second. So if this was P, what would be Q? A lot of people say, wait, how do we find Q? If we know P, how do we find Q? Boom, right there. Allie, great job. And Moira, great job. And Kenneth, great job. P and Q are complements. And so if this is make shot, 30%, not make shot is 70%. Boom, right there. My cursor was in the way. No worries. Looked right until you changed it. So great job right there. Those are complements. And it's important to know P and Q are complements. Let's continue on. And definitely, please go to Alyssa's review. She's great. We're trying to do as much as we can tonight. Obviously, I can't cover the whole everything in 90 minutes. We're giving it our best shot. So here we go with the next question. Let's go. The law of averages is a fallacy. The truth is what? What is the truth? This is known as the law of large numbers. The law of large numbers would say what? The law of large numbers says what? What does the law of large numbers say? The law of averages is a fallacy. The law of large numbers says... I can't talk, right? Past events do not influence independent trials. The law of large numbers states that we will see the true probability in the long run if we watch an event right there. So this one right here, you can multiply two independent events, but past events do not influence independent trials. The law of averages says something is due to occur. A fallacy means that it's not the correct way of thinking. So fallacious thinking, wrong ways of thinking. So you can't say I just flipped tails. Heads is more likely because it's independent trials. Law of large numbers, past events do not influence independent trials right there. Great job, Ali. That is what the law of large numbers says, is that we will see the true probability of an event in the long run. So it will occur. Maybe I am, no, Moira. Next question. Here we go. We're going to make sure we do some definitions at the end. So stay till the end if you want to practice the slope, intercept, r-squared interpretations. I think I have them in here. I'm trying to remember. So it's hard to put them on here. We know UT is 20% freshmen. We sampled 200 students. The 30 report being freshmen. What is N? Now I want to show you why we're doing these. A lot of these questions of chapter 13 come down to, what is it, Leo?
Notation, brother.
Know your notation. This is an easy one. They're going to get a little more difficult. You got it, Kenneth. And have your calculator out. Kenneth, 1,000 points for easy. So have your calculator out because there are going to be a few tricky ones. There are going to be a few tricky ones coming up. Notation. You got it right there, Allie. So what is N? N stands for sample size. And let's take a look at that formula sheet here. Hopefully everyone got it. Notation. So, some people said 0.15. That 0.15 is what? Here's the formula sheet right here. Know the formula sheet. Next or tomorrow we will be covering this. Last class we covered this right here, and this is the end of the test material tomorrow. This is end of test material tomorrow. We are reviewing Wednesday. So if you look right here, this formula is going to be pretty important here in just a moment, just saying. And so what is 0.15 was the next biggest answer. How are people getting 0.15? And let's do this real quick. Let's mark the notation. You ready? This is I want people to get questions right, so I want you to review with me. You ready? What is 20? We know UT is 20% freshmen. So what is that first thing? We know UT is 20% freshmen. We know, like, UT tells us UT is 20% freshmen. They tell us that. So what is that? They say that is true. So what is that? In notation, we know UT is 20% freshmen. We know it. So what is that value? It is true proportion. It is P. As soon as you find P, what can you find now? As soon as you find P, what can you find now? As soon as you can, great job, Ali, right there. As soon as you find P, you can find Q. Because P is 1 minus Q, or Q is 1 minus P. They're complements. So you can find that because that means 80% is not freshmen. So now we have here 200, which is being blocked by that, but 200 is equal to N. This is a confusing one that a lot of people forget. With an E? Yes, complement with an E. Great job. I like remembering because complement with an I is like great work. Complement with an E is the 1 minus. What is 30? A lot of people forget, and I'm throwing an extra 1,000 points. A lot of people forget what 30 is. What is 30 in notation? A lot of people forget this. So it's the amount of successes. Very close, not quite P hat. 30 is X, correct there, Ria. 30 is X. And how do we find P? What's the equation for P hat? You might have found P hat, Kenneth. What is the equation for P hat? And the actual success is correct. No worries, Kenneth. We're doing 1,000 points. Keep it up. Practice with us here. You got this. What is the equation for P hat? So P hat is what? You might be thinking about, well, no, just for P hat. Who can find P hat right now? So what is the equation for P hat? P hat stands for sample proportion. The P hat is sample proportion. It's not P is 0.2. It's 20% is the truth. Well, mu P hat, don't worry about those yet. P hat is what? You might be finding standard deviation. Think about this. Wait, don't think about any formulas. You ready? P hat is the sample proportion. What proportion of our sample was freshmen? Don't even think about any equations. Ali, you see it right there. Ali sees it. So P hat is the equation X over N. Does that make sense? But that you're thinking of the expected mean for the distribution of the sample proportion is equal to the true proportion. That is mu P hat. So P hat, which is not mu P hat, P hat is the sample proportion, which is what proportion did we see in our sample. Does that make sense? Mu P hat is the expected mean of the distribution of the sample proportion. So that is what we would expect. If you went out and talked to 200 students, so listen very carefully. If you went out and talked to 200 students, what percent would you expect to be freshmen? Don't look at what I'm writing. If you talk to 200 students, what percent would you expect? 20%. And that's what you're solving up here with mu p hat. Mu p hat says I'd expect 20% freshmen. You didn't see this in your sample, you saw 15%. Does that make sense to differentiate that? Like if you went out and talked to students, you'd expect 20% freshmen. You're like, well, if UT is 20% freshmen, then I should probably see about 20% freshmen. That's what mu p hat is. So good work right there. A few more tricky questions to come. Let's go check it out. Leaderboard first. Groovy Panda, great job. Woody Unicorn, good work. And Knowing Kitten and Swift Swan and Bright Hawk, excellent work. Here we go. So if P hat is expected value, then P is actual. Mu P hat, Rhea, real quick. Mu P hat is expected. P hat is what is observed in the sample. Mu P hat is the expected sample proportion. Does that make sense? We can review it more, but mu P hat means expected sample proportion, where P hat is your sample proportion. Good work right there, Rhea. Thank you so much for asking. Let's go to the next question and throw 1,000 points. Here we go with the next question. We know UT is 20% freshmen. We sample 200 students and 30 report being freshmen. What is P? P stands for true proportion. Remember, this is all about notation. Mark your notation throughout the questions. Practice these. Do the My Pearson homework. Mark the notation on the screen. Be able to read the questions, mark the notation. A lot of these, so we know it. P equals true proportion. It's all about that.
Notation, brother.
Make sure to have that notation down. P means true proportion. So you have to say, what is the true proportion? What is the truth right now? So if UT is 20% freshman, then no worries. Then 20% freshman. That's the truth. Let's continue on. Leaderboard Tom. Daring Penguin, so good to see you here. Next question, I did it quickly out there. Get ready. UT is 20% juniors. From 80 students, 30 are juniors. Find the mean of the sampling distribution. I promise this question is not as tricky as it sounds. It says find the mean of the sampling distribution. Find the mean. We were doing it earlier. Find the mean of the sampling distribution. So it wants you to find mu p hat. Mu p hat. Bye, Victoria. It wants you to find mu p hat. Mu p hat is equal to what? 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 Who started getting it as I started to shout mu p hat is equal to what? I think Ali was seeing it. So p hat is the percent you saw in your sample, and mu p hat stands for the expected sample proportion. That's why it's mu p hat. It's like what we would expect to see on average. So people were hearing it when I was like, mu p hat is equal to what? On the formula sheet right here, we have mu p hat, which is the mean of the sampling distribution right here. Oh, that's the wrong one. This is the mean right here. That's for the quantitative. We'll do that tomorrow. Mu p hat right there at the top. Mu p hat is equal to p. So this is the mean for the distribution of the sample proportion is equal to the true proportion. So all you had to do was find what value. To find this value right here, to say what do you expect to see, you just had to find what? Can we make it phonetic words so it's easier to type out something that was like mu p hat? Maybe. You just had to find p. So the mean of the sampling distribution for the sample proportion is equal to, and that's what that says. Who can follow me when I say this? The mean for the distribution of the sample proportion. The mean, which is the expected value, for the distribution of the sample proportion. You don't multiply them. It's like a notation thing. So P is the average, or the exactly right there. It means, put it this way. If 40% of UT was born in Tennessee and you talk to students, what percent of your sample would you expect to be born in Tennessee? Like if 40% of students are born in Tennessee, if you take a sample, which is P hat, what would you expect to see? I didn't even tell you, don't even worry about sample size or anything. 40% of students are born in Tennessee. You take a sample, you'd expect to see 40%. That's the most likely thing to see. Now there's going to be variation, which is why we have a standard deviation based on it. So the standard deviation tells you the variation within samples. Like here's the standard deviation within sample proportions. P hat, oh, I wouldn't say actual sample. It is kind of actual. It is the sample. It's what we actually sample. Actual oftentimes means truth, or sometimes when we talk about like residuals, actual minus predicted is a residual. But Allie, great job. We're 20,000 points. Keep up those answers. Allie, you're doing an amazing job tonight. I always try to be as exact as possible. Oh, I don't know. I should make an intro with Jolly. Yeah. So p hat is the sample proportion found by the formula x over n. P hat, and you won't use p hat here though. This is a notation that reads mean of the sampling distribution of the sample proportion. We need some Jolly content. I'll try to do it. I got some videos of I need to make some stuff with. Maybe over like Thanksgiving break we could do Jolly. I got some really good ideas with that. Next question. Here we go. It's all about notation with this chapter. Knowing kitten knows all. Here we go. Next question. We know UT is 20% freshmen. We sample 200 students and 30 report being freshmen. What is p hat? So p hat literally means sample proportion. He was being a bunny. He was doing his bunny thing. P hat literally means sample proportion. So you have to say what proportion of my sample was freshmen. So if you're wondering how to solve it, great job, Allie, right there with all the notes in the chat. So p hat means sample proportion. Then what does that mean? It's just what proportion of your sample. Who wants to show the math here? X over N, X over N. Great work. No worries more. I hope you got it. You did know it's just X over N. It's just sample proportion p hat is % of successes in a sample. X over N right there. So just think how many successes were there? What was my sample? Sample proportion is amount of successes out of total samples. Sample proportion. Can anyone tell me what Q hat would be mathematically? So Q hat, which we'll use on test 3, how would you find Q hat? If you know P hat is 30 over 200 or 0.15, Q hat, and there really you got it right there. Q hat's the complement of P hat. We don't really use that right now. It was on some of the homework a little bit to talk about standard errors, but 1 minus P hat is Q hat, 1 minus P is Q. They're just complements right there. Let's continue on to the leaderboard and do check out. We're going to do a little bit of notation or interpretations at the end, which are on the test. So make sure to know your interpretations. Here we go with a few more questions. Let's do it. 2 more questions. UT is 20% juniors. We find from 80 students, 30 are juniors. Find the standard deviation of the sampling distribution. What do you need for this? And I think it's quote 191. It's quote 191. I would love it if I knew it off the top of my memory. It is. It's quote 191. P times Q over N square root. P times Q over N square root. And it's not square root of N. It's P times Q over N square root of the whole quantity. So what is P? P is the true proportion. Who has P right now? Like, what is P? P is 0.2. What is Q? Great job. Q is 0.8. What is N? And Allie, you're an all-star. Great to keep it up. And Kenneth, great job too. 5,000 points. Thank you so much. 0.2 times 0.8 over 80 square root. There we go. Right there. P times Q over N square root. P times Q over N square root. Great job. Good practice. I'm off the boat. No, Kenneth, it's all right. Keep it up. Good work, Kenneth. Remember, it's all about practice and knowing your notation. 8-question streak. Great job, Rhea, right there. I keep running out of time. I do not have. That's all right. It's about practice and know the formula sheet. Know the formula sheet. Remember, the formula sheet even has hints for things like, knowing if things are mutually exclusive disjoint to add them, multiplying things when they're independent, complement being 1 minus the event, the regression equation with the residual being actual minus predicted. So there's actual minus predicted. We didn't talk too much regression or decision trees, but that is on the test. Here we are with the last question of the day, and Tiny Brian will be here to announce in just a moment. Here we go. From the sampling distribution of the sample portion, what is the third condition? What is the third condition? The first condition is random. The second condition is less than 10%. And check out last class. Can you explain what the variables mean again? Which things, Sydney, the notation? We can do that here afterwards. And do check out Alyssa's review. She's going to be starting that up here soon.
Newbot.
Do you want to announce? Do you want to announce the winners? Newbot wants to announce. Newbot,
Mubot, you want?
Mubot, you want to announce the winners? You want to do that? All right, let's go check this out. I'll stay on the screen here, Mubot. I probably people think it's me talking when Mubot's talking, but it's not. And we're gonna do a little more review after this. So here we go. Let's check this out. People swear. I say, Brian, it's you talking, but no, it's not me. I swear.
It is Mubot talking, not Brian. Brian, thank you so much. Here we are with the winners. Good job, Brian. You just stay still over there. Third place, Swift Swan, 20 Mute-Bucks, or 20, you email Brian. And no one can email Brian for the $20 Amazon gift card, $20 Starbucks, you call it. Also, Groovy Panda, great job. Brian's not frozen over there.
He's doing... I'm not frozen. I'm just chilling out over here. Mubot's talking away. Mubot's really talking. He's just hanging out over there talking right away.
Yeah, I'm just talking, everyone.
Good job, Mubot. Excellent work.
Thank you very much, Brian. You're really welcome there.
Hey, yeah, you're welcome too, Mubot. I appreciate it. What's up, Kenneth?
You're doing good, Kenneth. Great job. I want to be Mubot. Everyone wants to be Mubot. Awesome work. Third condition was the wait a minute. Success failure condition for sample proportions.
Thank you, Mubot. You're doing a great job. Success failure condition, and then large enough N for the sampling distribution of the sample mean. But with this time, Mubot, you gotta go away. You're gonna overheat if you stay here too long. You gotta go. Mubot. Bye, get out of here. Get out of here. Wait, no. Thank you, Mubot. Okay, good. He's gone now. He's gone. Okay. Bye-bye, Mubot. Please email me if you won. Okay, what things do you need to know how to interpret for the test? So let's go right here and put interpretations. What things do you need to know how to interpret for the test? What things do you need to know how to interpret for the test? And I want to point this out. A lot of people get these things wrong. A lot of people will know your notation. Blake, good job right there. Blake has an Tara, great job. Blake has an interpretation of R squared. Let me throw 5,000 points again. Thank you so much, everyone who stayed till the end here. Blake has an interpretation of R squared. Tara's mentioning the slope right there. And we also need to know how to interpret the what. Starbucks or Amazon. If something outside of the range, let me know. I guess, I mean, those are the easiest ones for me to just do and just send over because I can go on to Amazon or Starbucks and just like that. And great job if you won. Awesome work. So R squared, slope, and intercept. So you have to know how to interpret these. Let me get a little data up and going right here. Random. It's always random here. Let's get a little data going. 2 seconds as we'll open some data. Okay. So here is data. Here we are with some data. Oh, I need to take the timestamp. Interpreting. This is going to be at 1:25:43. Okay. So blank percent of the variation. Great job, Shelby. So much randomness today. Let's first start out by doing a regression. A regression uses what kind of variables? A regression uses what kind of variables? A regression uses what kind of variables? A regression, oh my gosh, uses what kind of variables? Quantitative. You see what I did? I actually selected it down to 2 quantitative variables. Let's take a look at right here and look at number of pets owned explaining yearly pet expense. So number of pets is in number of pets. That is the X is in number of pets. Does that make sense? Does how many pets you own, think of saying it this way, does how many pets you own what your yearly pet expense? Does how many pets you own what your yearly pet expense? Like why you spend so much on pets? Does number of pets you own what your yearly pet expense? Effect explain. I like explain because it's the what. Why do you think I like to say does number of pets explain yearly pet expense? Like why you spend a certain amount. It's the explanatory variable and they explain things. So does the number of pets you own explain why you spend a certain amount on pets? And we can't. Logan, you just throwing some facts down tonight. Another 1,000 points, Logan. Correlation and regression never show causation. We don't like words like prove, cause, will, must. Those are all bad words here. So don't say those in your interpretations, nor any question that says like this proves or it must. Don't do that. Like nothing proves. We don't say things are proving things. Great job, Logan. So here we are with the regression. What looks to be the first issue right here with the regression that you see off the bat? What looks to be the issue? What do you notice immediately? I'm kind of making them jump out right here. X is always the explanatory, correct. What do you notice right here? Outliers, QQ, straight enough. No outliers, plot doesn't thicken. So we're going to fit the line to it, and whew, that's an outlier. This is someone right here. They own 3 pets, and they spent $40,000. Now, I know someone, probably a little bit of colicking right here. What do you think? What do you think that's right there? 3 pets, $40,000 spent on it. 3 pets, $40,000 spent on the pets. Those are not 3 bunnies. Probably horses. Probably some colics. So you got bunnies over here. Bunnies are nice and 30. No, that's goldfish. That's goldfish down there. So what do we have first? This is the regression equation. Let's just call this expense. Somebody's expense is equal to this. Who wants to talk about how many pets they have and use this equation to solve for their yearly pet expense? Who wants to talk about how many pets they have and just would like to show how this equation is used and just solve for your yearly pet expense? You will have to write them. You will have to write them. So that's what we're going to do here in just a second. So use that right there and notice how those, that value is the intercept. That value is the slope. Now, the easiest thing to solve for will be people who what? The easiest thing to solve for will be people who what? Think of the easiest people who can solve this equation. Boom, Allie right there. We would expect, Allie, so good work. I probably would give you full points on that. And then you don't have to say if it's logical for this one, because sometimes it's not logical. But if someone has 0 pets, we would predict or expect. So predict or expect is a good way to talk about what the line does because it makes predictions. If somebody has 0 pets, then we would predict them to spend 2,000. Think what you're doing. You're just plugging 0 in for this. Does that make sense to everybody? Expect, exactly. You could say it's kind of what the equation predicts. You could say, like, if you want to be very mathematical, you could say the mathematical equation predicts that people who have 0 pets would be likely to spend this amount. So that's what that would do right there. So you're just plugging 0 in for pets. Does that make sense? How much? Brian has 2 bunnies. How much do you predict Brian would spend? How much do you predict Brian would spend? And how are you doing that? How much do you predict? We're doing a few questions here, then we're doing the interpretations. Do check out Alyssa's review. I'm probably going to go for another 10-ish minutes. So you're going to times it by the slope right here. That's the slope coefficient. You're going to put in 2 pets. So figure out how much Brian is spending on pets or predicted to spend. How much do you predict? Great job right there. Blake's writing it the interesting way of writing it. You're going to go right here on this. And what did you just solve for? So solve this out, and what did you just solve for? What is that value in notation? What is that value in notation? So when you put the 2 in right there, you're solving for what? And then we're going to do interpretations here in a moment, but we're just practicing this equation. There's a big review of this chapter right now because this one's one of the oldest. What are you solving for? If you plug 2 in right there, you're solving for what? Like this value over here is what? Well, 2 is how many pets, which is Brian's x is equal to 2. And Brian's predicted expense, Brian's predicted pet expense is the solving of the equation. It is predicted that Brian will spend $924.69. That's what we predict or expect. Exactly. Predict or expect. Solving for the amount you would spend. Predict, exactly. Great job, Sophie. Sydney right there. We are solving for the predicted amount that Brian would spend given he has 2 pets. Like, this is the mathematical solve. If Brian tells you that he spends, let's say, $1,000 a year, so I do spend, let's say, $1,000 a year on Morty and Jolly because they're worth it, then what value did I tell you notation-wise? I want to know the notation for this. If I tell you I do spend it, Chelsea and I do spend $1,000 a year, what did I tell you notation-wise? So now, and great job, Tara. So if I tell you I do spend $1,000 a year, what did I tell you? The actual. What is that notation? Great job, Allie. Oh, so the actual, the y hat is the predicted, the y is the actual. And you could put like predicted right here. And what do you think I'm going to ask? No, good practice. This is the practice. And so what do you think I'm going to ask you to solve for next? If you know the actual and the predicted, and this is the way it would look. So there's the line, and Brian's going to be right here. What quantity am I going to ask you to solve for? So that value right there, that point is the y. The value here is the y hat. The residual. What's the difference between y and p hat? So p hat is used in sample proportion, which is dealing with categorical data. Good question, Sydney. So p hat means sample proportion. Y hat means predicted from the regression equation. They're both kind of from a sample because y hat is when you do predictions from the line from your sample. And great job, Tara. The residual is positive. So it's going to be actual minus predicted. E equals actual minus predicted, which we like to say residual equals actual minus predicted, and then solving through the formula right there. Always check the sign because look at this, the what right here, the actual is what to the predicted. So the actual is what to the predicted. The actual is what to the predicted. Like Brian is doing what? He's spending more than predicted, so it's a positive residual. And the actual, because this is the actual point, and the predicted is from the line, and I'm higher than what I was predicted to spend. So no, technically, oh wow, underestimated. Oh, just got my toe. Underestimated. But good, Tara, great work. No, so we underestimated how much Brian would spend. Does that make sense? We underestimated how much Brian would spend because the estimate comes from the line. 24 still watching. We love it. So here's the big things. So this is, let me write regression review. Regression review. And now let's do interpretations. Interpretations are worth how many points on the test? I'll just flat out tell you, and I think some people know. Interpretations are worth how many points on the test? Interpretations are worth how many points on the test? 12. 12 points, and you will be writing them down. So get your flashcards out, get your note cards out, and get ready. Here we go. I need to restart the computer. The first quantity to know how to interpret will be the intercept. And remember, write this down, because I can write down, so write it down too. So when x is equal to 0, we expect y to equal b sub 0. Mortal Kombat. Comment if not logical. Okay. So when x is equal to 0, x is the name of the x variable. X is what? What is x here? X is the name of the x variable. So what is x here? So look at the equation. The equation is y equals b0 plus b1x. X is what here? And so x is what in this example? X is what? X is number of pets. We expect y, and that is y hat technically. So, but the name of the y variable is expense, but this solves for y hat. So we expect y, which is the pet expense, hence expected or predicted, to equal to b0. And b0. So try writing this down. Try writing this down. Try writing this down. Write out the write it out right now because you're gonna have to write it out in the future. So try writing this down. When the number of pets is equal to 0, we expect pet expense to be equal to this. Now you might, what might you comment? Like you might add a comment to that. Some great, I would accept that. I'd accept that. But what might you say? I mean, you might add a little, I'd probably accept it. I'd say, this would be nice. That one's logical enough. When someone owns 0 pets, we expect pet expense to be this. You might say, it's kind of odd that people who don't own pets are spending money on pets. Maybe it's like friends' pets or whatever. I don't know. I think it's logical enough. I'll show you an illogical one. My favorite example of an illogical one I actually do inside of R because the data set's there, really easy to do. 2 seconds. So this is regression in R. Regression in R. Okay, so this is data survey 10 back in the day. Oh, I gotta load it. I gotta restart my computer. Reg class. Okay, 2 seconds. Survey 10. LM height. Weight. Data equals survey 10. Okay, so what is the estimate of the intercept? Great job. Great job, Sydney. Sydney, 1,000 points. Let's make Sydney a mod too. Just tell me right now, what is the intercept? What is the intercept? This is the same way it looks in jump output. It's just being displayed for you a little bit differently. What is the estimate of the intercept? What is the 56.34? And if you go over to jump, it looks the same. It's just down here, the estimate of the intercept. Good night, Logan. Thank you so much. Excellent work tonight. And check out this video is recorded if you want to check out more. We're going to be interpreting all of these and seeing how they're logical, illogical. So think about this. What is Brian's x variable here? Remember, when x is equal to 0, we expect y to equal b0. And you can say on average right there. Expect they should. Greater than nice. So what is the x variable name? What is the x variable name? What is the x variable name? And then think about the interpretation. It's weight. So how is this interpreted? When somebody's weight, think about the interpretation. When x is equal to 0, we expect y to equal b0 on average. So when someone's weight in pounds, try to finish my sentences right here. Try to like be typing it out and finishing your practice. Be like, oh. And then think over what you're saying. So when someone's weight in pounds is equal to 0, we expect their height to be 56.34 inches on average. Throw a little on average in there. Some graders are particular. So does that make sense? And please argue any of these. When weight in pounds is equal to 0, we expect their height to be 56.35 on average inches. Some people want the on average. I really don't care. To me,
It doesn't matter.
because you're saying expect. This is not logical, and then you might say because if you can't weigh nothing, we can expect their height to be 50% on average. This is not this is illogical because someone would not be any height is if they did not have any weight. Great job, Ali, right there. That's exactly it. So you'd say it's not logical. After each interpretation for y-intercept, would you suggest putting it? Yeah. Just be careful, Tara, we're throwing you some 5,000 points. Great suggestions, Tara, right there. The careful things to do were graders, because they're very particular. You can throw on to be careful. Mention if logical or not, like if it makes sense. To be careful, add on average at the end. This one, it's a little subjective, and I definitely look over anything people complain about and say, hey, I think I shouldn't have gotten points off here, because, you know, we train our graders on how to grade these, but if you do something outside the box or a little different, I also tell my graders that you don't need on average even for the slope. But I just gotta remember sometimes the teachers want that, but just make sure to have an interpretation down. I want everything graded so you know how it's gonna be graded. Is that just for the intercept for all interpretations? Throw it on for the slope too. Some of them want it. So how do we do the slope? So here's the intercept, right? How do we do the slope? What is the interpretation for the slope? Which is also another 4 points on the test. What is the interpretation for the slope? What is the interpretation of the slope? You don't have to mention the slope's logical. Great job, Allie. Good job. If I was, yes, I'll be changing it later tonight, probably. They'll be changed before the day of the test, or before the Tuesday, because that's when some people are taking it. Thank you, Allie, so much. Great work tonight. So for each 1 unit increase in X, we expect Y to increase/decrease by B1 on average. That's where they usually get you on average. So with this right here, take a look. How would we interpret this? And think about what this means. For each 1 unit increase in X, we expect Y to increase by B1 on average, or decrease. So first off, the increase decrease. would need to be noted by the sign of the slope. So the increase decrease is going to be decided if the slope are positive or negative. And then the coefficient of the slope, let's go with a nice, that one. And the x is this, and the y is this. There it is right there. For every pet that we have, we expect an additional, yeah. For each additional pet, What is B1 again? B1 is the coefficient of the slope. It's the numeric value. Does that make sense, Shelby, where I have it highlighted, color-coded here? I hope the color coding can help. So I try to color code it so you can see where exactly each part of the notation is. So for each 1 unit increase in the pet someone owns, didn't know the name. Oh, so B1 isn't a name. B1 is a quantitative value. B1 is known as the coefficient of the slope or the coefficient of the first x. So this can also be called in multiple regression x1 because it's the first x in the model, but that's multiple regression. The second x gets coefficient x2 or b2 for x2, but we're not doing multiple. We're just doing simple regression. More on that in other classes. But for each 1 unit increase in the pet someone owned, but Sydney, great job right there, said for each additional pet that someone has, we expect that their pet expense would increase by $323.8 on average. Does that make sense, Sydney, right there? For each 1 unit increase in X, and think about what 1 unit means in context. That's a good thing to do right here. For each 1 unit increase, give some context to this usually, which sometimes you'll be like, what does it mean for each 1 unit increase in pet? Will the interpretation always look like this when we see on the screen right now, like expense? It could look like this, or it could look like this right here, where we show you these values, where this is B0 and that is B1 respectively. So that is if you point in on this, that's the estimate of the intercept, and that's the estimate of the slope coefficient. So this right here is B1, and that is B0. Those are the estimates of B1 and B0 respectively. It could look like that. I think we're pretty fair on it. It's just that is the estimate of the intercept. That is the estimate of the slope. Don't worry about standard error and stuff like that. Not on this test. So any other questions right here, Blake? Because now we have to interpret the what. So now for each 1 unit increase in X, we expect Y increase on B, or increase or decrease on B1 on average. Just look at slope, positive or negative. What's the last thing we have to interpret for a regression? R squared. So R squared is R squared. It's correlation squared. Now watch out, because you have to check the sign of the slope. Is correlation right here? Great job, Blake. Is correlation positive or negative for this right here? Is correlation positive or negative? Is correlation positive or negative? Do we only use these numbers if... Oh, and then you're talking about significance of the model, Sydney. Oh, let's talk about that next. Blank percent of the variation in Y is explained by the variation in X. So blank percent, it's positive because there is a positive slope to it, and that means correlation's positive. So R squared is the percent. So how would you interpret this? And then Sydney, I'll answer that one. How would you interpret this? So I've got everything highlighted for you. You don't technically need the positive sign now. Try filling in the blanks. Blank percent of the variation in Y is explained by the variation in X. So blank percent of the variation in Y is explained by the variation in X. Let's put in caps right here. Do not mention correlation. Do not mention correlation. Don't start talking about correlation. Do not start talking about correlation here. People lose tons of points. They start talking about like correlation is this. No. 13.83% of the variation in pet explains is explained by the variation in number of pets someone owns. Boom. 13.8% of the variation in you plugged in some extra values right there. It's the name of the Y variable and the name of the X variable. And so great job. Good practice, Blake and Tara right there. And so Tara, perfect answer. Let's throw you more points. Blank percent of the variation Y is explained by the variation X. So you'll plug in the variable names there, and you're just like, well, 13.8% of the variation in someone's pet expense is explained by how many pets they own. Think about this logically. Probably something else that explains your pet expense is what? Wrong answers with points. It's not just how many pets you own. What else would explain your pet expense? It's not just how many pets you own. What else would be variation in how much your pet expense? The type of pet. So there's other sources of variation in pet expense. It's not just how many pets do you own. There's other variation, and that's remaining like 86, 87% of the variation is like from other sources of variation, like how much do you smother your pets with love? It depends. The horses, then you're going to go broke very quickly. And so another great question was about the 0.05. 0.05 is the value of the slope of the p-value, 0.05 is the value for the p-value of the slope at which it's statistically significant. This model is statistically significant, so good job, Sydney, right there, because of that value I've highlighted. That is the p-value of the slope, and p-values are statistically significant when, major important stuff for test 3, p-values are statistically significant when a p-value is statistically significant, which means unlikely by random chance, when what? A p-value is statistically significant when what? The value of the p-value is what? Jump, put stars on them. Is less than 0.05. Less than, and equal to 0.05, technically not statistically significant. So great job right there, Blake. And we have one last thing to do. Slides. Last thing, are you ready? Analyze. Predictive modeling. Partitioning. Great job, Catherine. What is Brian making right here? I am making a what? I'm removing identifiers, and I'm removing things that act like identifiers. So I'm removing identifiers. There's one more. Maybe not. Maybe not. So I removed identifiers or things that act like identifiers. I'm making a decision tree. Great job, Caleb. Make Caleb a mod too. Thank you, Caleb, for being here all tonight and working and practicing. And run over to Alyssa's review after this. Awesome shout out to Alyssa. I was trying to end on time, but I wanted to do these final things right here. Let's predict if somebody is in the honors program. Let's predict that. Okay, we're going to predict if someone's in the honors program. Ready? Let's do it right here. Let's do this. Here we go. So if you look at this right here, this is a decision tree with categorical data. You have right here the response to the Y variable, and the blue people are in the honors program, red or not. So the first thing that explains someone being in the honors program, obviously, is what? Which the first split's the most important split in the tree. The first split, which explains someone being in the honors program, is what? Is somebody's what? Their GPA. And think about this. Right now, this tree explains 12.3% of the variation in whether or not someone's in the honors program. Does that make sense? 12.3% of the variation in people being in the honors program is explained by GPA being at or above this, but the tree basically. Is it all going to be GPA? Oh, there's marijuana. Oh, there's marijuana right there. So we can't split there. It's too small. There's a leaf requirement. Really? Oh, you can. I was like, it's going to do it. And how close they live on campus. Interesting. Let's split here again. Oh, man. All 6 of these people right here are in the honors program. All 6 of these people. I'm actually going to prune this. Let's prune here. Okay. So here is, great job right there. Thank you, Tara, right there. Here is our tree. How could I look more closely at these groups? How could I look more closely at these different kind of leaves and see the individuals in them a little bit better? How could I look more closely? A leaf report. A leaf report lets you see the individual 1, 2, 3, 4, 5 leaves in the tree. So here's the leaf report right here, and it lets us see. Now, when you look at the proportions, which leaf 1, 2, 3, 4, or 5, has the people most likely to be in the honors program? Leaf 1, 2, 3, 4, or 5. This is 1, 2, 3, 4, and 5 down here. The proportions makes it easier to see that leaf 1 has the people most likely to be in the honors program, because this is the response to the Y variable up here where it says yes, in the honors program. So this is the most likely people. These are the most likely people in the honors program. Now, when you look at the leaves, they're the bottom of the tree. Leaf 1, 2, 3, 4, 5. Like when you think of a tree, trees have leaves at the end of a branch. So these are the branches, literally called branches. At the end of the tree, we have the leaves. So leaf 1, these people basically what? Oh, it's so easy to describe them. How would you describe, just summarize it. How would you describe someone who's all the way down here? And they're very likely to be in the honors program. I think they have about a 40% probability to be in the honors program. You could describe them as two things. They have to go through the tree. They have to follow down this pathway to get to here. So they have to meet all the, you have to say yes to this, yes to this, yes to this. And look how it's the same variable. It's split on twice, but you can do that. So these people right here, they what? They have a GPA greater than or equal to 3.84. Also, their GPA is greater than or equal to 4.32. Also, they live on campus. Boom, Logan. Logan, that's... Yeah, Logan, I remember you because you've got the high... That's not Hyperion. That's... is that Hyperion? Who's that? It's the dude from The Boys, right? Weren't you here last time with the Boys icon? That's exactly... Because it's redundant to say, like, above 3.84 and then 4.32. What's his name? Don't ruin any Boys for me because I want to see it. Yeah, The Boys. Yeah, I need to check that out. That's on my list. I'll probably watch over break or something. That's on my list. That looks so good. Like, man, I love dystopian or kind of... Did you see Invincible? Homelander, that's his name. Did you see Invincible? Invincible was... Oof, that was good. I can't wait for some Invincible season 2. I like when people from other classes... Yeah, it's really great times right here. Thank you, Logan, for being here and good practice. So think about this. If someone said to you, look at my tree, obviously I know a lot about people who are in the honors program. I mean, yes, but no. You know a little. Because right now, think about the interpretation. Blank percent of the variation in being in the honors program is explained by the variables in the tree. What's the answer to the question? Blank percent of the variation in being in the honors program is explained by the variables in the tree, which means there's a lot we don't understand about being in the honors program. Things that we have not accounted for. Variation in being in the honors program that we can't understand right now currently. So it's like, why is someone in the honors program? Well, there's something. 17.3, boom, R squared right there. Because that's what R squared is. It's the amount we understand in the Y variable based on the X in simple regression. Simple means 1X. Or in decision trees, the variables in the tree, because right now there's multiple variables. How could I look at how good my R squared is doing? More hints for the test. How could I look at how good my R squared is doing over the splits? Maybe look at its history. How could I look at the history of my R squared over its splits to see how it's doing? How could I look at that? Maybe go to where is it? Split history. There it is. It's doing is what it's doing. Split history is I don't know. The leaf report shows you what the leaves and the amount of individuals and the percentages within the leaves. We can look at the split history to see the history of the R squared. So split history shows you after each split, good definition to write down. Split history shows you after each split the increase to R squared. R squared must go up after each split because you're adding X's and X's like to explain. So by adding an X to the tree, you are literally explaining more. You must be explaining more because X is explained. So you add an X, it explains. There is, well, because then the X would have a 0 coefficient. It is theoretically possible to try to add something and it has a 0 coefficient, which would not improve it at all, but then it's not technically added. So in the technical sense, if it's added and has a coefficient, which means added to the tree, then it must, what did it do? Reduce Gini being impurity. Sorry, I'm just thinking all technical, or sums of squared error reduction for quantitative. I love some statistics. It's a lot of fun. Any last questions right here? And thank you so much, everyone, for staying. I had a great time, and I really like reviewing. If you can't tell, I just love these topics. It's so cool what we can do with data. I love me some data. We'll head back here to the main screen. Let's go to the Davey 504 screen. There we go. Stay until the end. That's what we do right here. We're chilling out. Just chilling out. Catherine, have a good night. Well, thank you so much, everybody. Great review. You're welcome, George. Glad you had some fun. Hopefully, learned a lot tonight. Had some fun. I'm just gonna wait. Maybe I need more room on the side of my screen. Whoa! Here we go. Off the side of the screen. Can I get full screen over here? Almost works. There we go. You're welcome. Great work. Woo! So much room for activities. Just don't go over there. We don't talk about over there. You're welcome, Sydney. Great work. Now go watch Derrick Henry dominate. Whoa! My fantasy team is winning. Last I saw. With that, can we get 10K for saying I'll throw you? I'll tell you what, we're throwing 5K right now. We're throwing 5K right now, but tell them 10K tomorrow for being good sports on the weekend. We lost. It was a good game. Wish it was closer. Wish we won. But, it was a good game. What else can you ask for? What else can you ask for than number 1 playing number 2? And they got to win, but maybe I don't want to say we let them win, but we're still awesome. That's all I'm saying. UT's still number 1 in my heart. That's what I think about UT right there. But good job, Georgia. Congratulations. You won fairly and you won well, and you deserve to be number 1. But you know what? If we see you again next time, we're gonna win. You say, I hope we never say we lucked out against Tennessee once. It's not lightning doesn't strike twice. That's why I say Georgia. Lightning doesn't strike twice. No one gets lucky that twice. But we all like a good rivalry. With that, stay positive. Make sure to treat everyone with respect. We'll see you next time. Bye for now, everyone. Bye. Good luck. Good work.